Okay, so let's continue. Determine the value of k for this equation. And again, it's when two equal roots just means it's the vertex is on the x-axis. Two different roots means it hits the x-axis twice. No real roots means it doesn't hit at all. So it's the same thing over and over again, okay? So I'm going to sort of speed up. They're just changing where the k is, and they're making the divisions different. So remember, it all comes down to the discriminant, which is b squared minus 4ac. Okay, so it's all about figuring out what the a, b, and c is. Sometimes the k is going to be where the b is and where the a is. Sometimes, as in this case, it's both, right? So it's going to resolve, though. It's probably going to have a quadratic solution when this is the case. But you just always remember what number is here. Well, it's the number k. What number is here? It's the number minus 2. That's b. That's a. And what's this one? It's k. It's c. So where we see b, we're going to put in minus 2. And minus 2 squared is 4. And then it's minus 4 times k, which is minus 4k squared. So yes, this is going to have two possible solutions because of the square. When we subtract 4 from both sides, because that's what we have to do, whenever you see a 4 in front, it's like plus 4. And since everything's being added or subtracting, we have to subtract that 4 to get rid of it. So you get minus 4k squared is equal to minus 4. And when we divide by minus 4, we get k squared is equal to positive 1. And when we take the square root of both sides, we get an answer that k is either positive 1 or k is equal to minus 1. This means for the discriminant equals 0, in other words, to have two roots that are the same, in other words, to have the vertex on the x-axis, k would have to be plus 1 or minus 1, which is another situation we're going to have where the parabola is either going to go up between minus 1 and 1, or it's going to go down, whatever. We'll figure it out. So that's the answer for when we have two roots that are the same. K is 1, k is minus 1. The only thing that changes is instead of equal zeros, above 0 is the same as positive. So for this is for above 0 is the same as positive. So this is for two roots that are not equal. And it's the same calculation. We're ending up with k squared is bigger than 0. Sorry, bigger than 1. When we take the square root of this, we get k is bigger than 1 or k is smaller than minus 1, because the minus, you have to change the sign. So this essentially means that for it to have two x-intercepts, it's going to have to, this k value would have to be bigger than 1 or smaller than 1. Which means in between minus 1 and 1, it would have no real roots. It'll be before. And this is always easier to see when you actually put it in quadratics. So we're talking about x squared, example 3, kx squared minus 2x. And I'm saying k is 1 or minus 1. So minus 2x is the middle. There we go. So in this one, it's going to have, let's see, kx squared is either 1 or, I think, positive 1. Let's go back to the question, make sure I got it right. Plus k minus 2x, kx squared. So I'm saying it's 1 minus 2x. So where's that parabola? Oh, I'm not zoomed in well now. I'm too far zoomed out. What did I screw up here? Oh, it's not on. That doesn't help. There we go. So there's the one where we have when this is 1, positive 1, and then when they're both, when this is minus 1 and this one is minus 1, we get the same sort of situation. It's just it's facing upside down. Any other situation, let's say when this is minus 0.5 and this is minus 0.5, we can see that we have 2. So anything, and even positive 0.5 and positive 0.5, we have 2. But anything that's above 1, 1.5 and 1.5, we can see it's above the x-axis. Even with 1.1 and 1.1, it's above the x-axis. Even 1.001 and 1.001. So any value above 1, and you might say, oh, no, that's touching. When you zoom in, it's not touching. So that means any value above 1 or below -1, we have no real roots, which was the solution we came up with, I think. Oh, we came out with a different solution. We said when k is positive, when k is bigger than 1 or smaller than -1, we'd have 2 real roots. Let's see if I got that wrong. Yeah, I got that wrong somehow. When k is bigger than 1, so let's pick an obvious one. K is bigger than 2. I might have to solve this one again just to make sure I got it right. So that's there. And I'm claiming when it's this, when it's between this, it has 2 roots. So let's see how I screwed this up. 25. Okay, so let's see if I screw this up. So again, I get, it always comes down to b squared, which is 4, minus 4ac, which is minus 4k squared. And when we get it, we're still end up with k squared is equal or bigger. So when it's bigger than 1, this means there's 2, or bigger than 0, it's 2 real roots. Oh, I know where I screwed up. Here we go. I screwed up my own stupid rule. So when I get when it's bigger than 0, it's got 2 real roots. But right here, when I divided by -4, I had to change the sign, smaller than 1. So there's a screw up right there. It's very easy to screw up. And when I square root it, it's either k is smaller than 1 or k is bigger than -1. So that means between -1 and 1, I have 2 real roots that are not the same. And we see it here. Yeah, that's between -1 and 1. We have 2 real roots. And then when we solve the same thing for smaller than 0, so remember that we have to start at this stage, right up here. It's smaller than 0. That is when there are no roots, doesn't cross the x-axis. We have this situation, minus 4k squared is smaller than -4. When I divide by the -4, I get k squared is bigger than 1. When I square root it, I get k is bigger than 1 or k is smaller than -1. That's when there's no real roots, which is what we're finding. So that was my screw up there. Doesn't help when you're doing these things if you mess it up. And then they give you another k. So obviously k is on the test a few times or at least once. And there's different tricks for each one. One root is 5, so this is interesting. Because this one is so hard to solve, so each one he makes harder and harder, we have to know what the heck is going on with my life right now. Why can't it? There we go. So in this case, they're saying one root is 5, which means x is equal to 5, which means it has a x-intercept of 5, 0, which means it has a factor of x minus 5. That's what that means. So they're giving you some information here because I actually don't know why they're giving you this bit of information. Maybe because it's too hard to solve, but let's find out. So again, the discriminant is b squared minus 4ac. And in this case, the a is 2, the c is minus 15, and the b squared is k. So you get k squared. And what's minus 4 times minus 15? It's minus 60, or plus 60, and then times 2 plus 120 is equal to 0. Now, why would they tell us this? Oh, let's try it this way. One root is 5. Why are they telling me one root is 5? It's such a weird thing to do. One root is 5. So x minus 5 is one of the factors. Oh, and we know this has to come out to minus 15. So we know this has to be x plus 3. for this to become 15, minus 5 times plus 3. And then one of these has to be a 2 because of this 2. So it's either this one or this one. So it'd be 2x squared plus 3x minus 10x minus 15. So it's either that or this. So maybe they're trying to test us on that. It has to be one or the other. So let's put this aside, knowing that. It has to be one or the other because the only way you can come up with this number is when this number multiplies this number. They told us the root is 5, which means the factor is x minus 5, which means this must be 3. The only question is because of this 2, is the 2 here? Or is the 2 there? So let's put this aside. And we'll do the normal discriminant. I think let's make sure that's what they're asking. No, it doesn't want any discriminant at all. So it's just saying determine the other factor, or the value of k. Well, when we expand this one, we get 2x squared plus 3x minus 10x, so that's minus 7x, minus 15. So that's that, k. And when we get this one, the 2x is over here. So we get 2x squared plus 6x minus 5x, so plus x minus 15. So I guess our two possible answers are k is minus 7 or k is 1. I guess. Let's see if that's true. It's either 2x squared plus x minus 15 or 2x squared minus 7x minus 15. Both of these should have a root at 5, and that one does. This one does not. 2.5. Oh, so there we go. That's right. So this one, it cannot be possible because the root here is 2.5. When we set this equal to 0, it's 2.5. So this is the only one that's possible. So that's the only possible k value.